Okay, so first problem, we want to write a paragraph proof to prove the converse of the alternate interior angles theorem. And the converse of the alternate interior angles theorem is if a pair of alternate interior angles is congruent when a transversal intersects two lines then the lines are parallel. And all these theorems are in your book. You have a moment to take a look at those today and just glance at those. But it's basically the backwards version of what we saw in Chapter 2.1. In Chapter 2.1 we had two parallel lines cut by transversal. We had the alternate interior angles congruent. Now alternate interior angles are congruent. When you see this picture, notice the lines are not marked as parallel, right? But we have two lines cut by transversal. We're told angle 1 and angle 2, which would be the alternate interior angles in this picture, right? They're on opposite sides of the transversal or inside the two lines, right? So if a pair of alternate interior angles is congruent, when two lines are cut by transversal, then the two lines must be parallel. That's what the converse of the theorem states. Right? The book might have not the exact same wording as I do, but the basic meaning is there. Right? I didn't memorize the word for word theorem, but that's what it says. So with that in mind, we're trying to prove this fact here. I'm going to shrink it up so I've got room to write my proof. And here's my thoughts. I'm starting off with my given information, what's highlighted, that 1 and 2 are congruent to one another. I know that angle 1 and angle 3 are congruent because they're vertical angles. And if we're trying to prove the converse of the alternate interior angle theorem, that means the converses of the other theorems are alive and well. So I've got the corresponding angle theorem, I got the same side interior angle postulates theorem. So I've got those converses of those theorems which we're going to accept as true. They all say the same thing. If the corresponding angles are congruent, then the lines are parallel. If the alternate exterior angles are congruent, the lines are parallel. If the same side interior angles are supplementary, the lines are parallel. So I'm going to get that 1 and 3 are congruent. I know 1 and 2 are congruent, and 2 is congruent to 1, 3 is congruent to 1, so by the transitive property I can say that 2 and 3 are congruent. At that point I have corresponding angles. I can use the converse of the corresponding angle theorem to show the lines are parallel. So that's my thought process on this, and then I just have to write the proof. And again, every time you're going to do a proof, first step is that thought process. Think about how you're going to write it, what order you're going to go in, what types of facts are there, and make sure that you believe it's true. Right? I can't remember a problem in the book where the proof was not true. But you just have to convince yourself that it is true. Know how it's true, understand why it's true, and then put it down to paper. Paragraph proof, we just write down what we know. This happens because of this, this happens because of this. I like to start off with the words we are given. We are given angle 1 is congruent to angle 2. Next, I wanted to say that 1 and 3 are congruent because they're vertical angles. Vertical angle theorem says if there are vertical angles, then they are congruent. Right? So 1 and 3 are vertical angles. I can see that with my eyes. So you don't have to define vertical angles to see what they look like. So I can say by the vertical angle theorem, angle 1 is congruent to angle 3. So that's my starting off information. Those two things I know. One thing is given, one thing is by the vertical angle theorem. And I'm going to move on now to say that since 2 is congruent to 1 and 3 is congruent to 1, that's the transitive property. Again, and don't get worried about the order. It doesn't have to have this thing here and this thing here. A congruence, this could be just as easily B is congruent to A. It means the same thing. So when you're looking at a congruence or an equality statement, the order doesn't matter. So first equals second, first congruent to second, second congruent to first doesn't matter. So the fact that 2 is congruent to 1 and 3 is congruent to 1, that two things are congruent to the same thing. Right? So by the transitive property, angle 2 is congruent to angle 3. We've been using substitution a lot in a situation like that, but with congruence, it's really better to use transitive property. It's more official, I guess. All right. If you want to use transitive property for the equation stuff too, you're allowed to. You can still call it substitution in that scenario. Okay. I'm saying they're interchangeable. If you said substitution instead of transitive property, I'd probably count it right. But again, with congruence, transitive property is more correct. With equations, I guess substitution is a little more correct, but I'm not going to say one is better than the other in either case. At this point, 2 and 3 are congruent. 2 and 3 correspond to one another, they're corresponding angles. And the converse of the corresponding angles theorem states, if two lines are cut by transversal such that the corresponding angles are congruent, then the lines are parallel. Okay, that's what's happening. We have two lines cut by transversal, the corresponding angles are congruent, so the lines must be parallel at this point. So by the converse of the corresponding angles theorem, L is parallel to M. All right, and be careful, if you're trying to say that angles are congruent or angles are supplementary, you're using the theorems. You're using the same side interior angle postulate, you're using the alternate interior, alternate exterior, or corresponding angles theorem to say that these things are either congruent or supplementary. If you're trying to say the lines are parallel, if your conclusion is the lines are parallel, you're doing the converse of those theorems. All right, so a lot of times last year with geometry classes, they got those backwards. So if you want to say this, if you want to say lines are parallel, you're doing a converse of the theorem. All right. If you're trying to say that, if I wanted to say angle 2 is congruent to angle 3, that's my conclusion. It would have just been the corresponding angles theorem. I would have already had parallel lines cut by transversal. So if your conclusion is parallel, you should have a converse of the theorem. If your conclusion is a congruence or a supplement, you should have just the theorem itself. So make a distinction in your brain about the difference between those theorems. That'll be the best thing as far as writing proofs are concerned in this section.